Please welcome Developer Programs Engineer, Peng Ying.
I love the production value. Thank you. My name is Peng Ying. I am a developer programs engineer for Google, and I focus and I help developers on distributing web apps and focus on monetization. So today, I'm here to talk about exactly that. How can we help developers like yourself easily distribute and monetize your web apps? If you're interested in what I have to say, or if you have any questions for me, please follow me on Google+. I'm +Peng Ying. And also, if you want to have a conversation about this talk, please use #GDD money. So this is an old internet adage. It's from an episode of South Park. I don't know how many of you know what South Park is. It's a US show, but it's hilarious. There was one episode where they focused on underwear gnomes. And the business plan for these gnomes was that they would go out, they would steal underwear, and in step 2, I have no idea, and in step 3, they would profit. And that's kind of similar to the web app world today. I mean, a lot of my colleagues have given great talks about how you can create immersive experiences with web apps, really awesome web apps. But going from creating an awesome web app to creating a successful web app is a road that isn't really clear. And what I'm here to show you today are 3 Google products that can help you through that path and really easily implemented to help you through that path. So the first step is always distribution. How do you get your web app into the hands of your users? And one of the easiest ways to do that is to use something called the Chrome Web Store. And what the Chrome Web Store is, it's analogous to the Android marketplace, but for the web. It's a place that allows users to discover great web apps, extensions, and themes for Chrome. Also, we have over 200 million installed users for Chrome as of this point. So you can easily reach all of these users if you distribute your web apps through Chrome Web Store. If you've ever noticed that, if you open a new tab, Chrome Web Store is displayed front and center for all of your users to see. There's also several other benefits for developers. The first one is that it's very cheap to distribute your web app through Chrome Web Store. There's only a $5 fee. Also, Chrome Web Store removes a lot of the red tape associated with distributing your apps. You can choose multiple monetization models. So these include one-time payments, so pay up front. Say you want to sell your game for 99 cents or $1.99. Subscriptions, so every month or every 2 months, you charge your customer a fixed amount. And lastly, in-app payments, which is something called the freemium model that I'll be talking about a little bit later in this presentation. We also have no review or approval process. Once you click the Publish button, your app is live on the Chrome Web Store. There's no restrictions on the advertising platforms that you want to use, so you can choose to use AdSense, DoubleClick, or any other ad platform for your web app. And on that same note, because it is the web, there's no restrictions on platform, there's no restrictions. The web is an open place, and you can distribute any web app within the Chrome Web Store. There's also a few other benefits for developers. We found that Chrome users are typically early adopters, and we've done a case study with a few of our partners. With World Golf Tour, what they've noticed is that Chrome Web Stores, because they are early adopters, they find that these early adopters are more engaged within the web application. So World Golf Tour has found that they play 23% more, and more importantly, they spend 147% more. If you're interested in this case study, you can find the link at the bottom here. But don't bother copying it down now, because I'm going to give you the URL to this presentation at the end of the slide deck. Another one of our partners, SpringPad, has found that Chrome users have 100% more engaged within the application. So we know a few things. We know that Chrome Web Store has a lot of users, over 200 million users. We know that it's cheap to use and that there's no red tape, so it's very easy to distribute your apps, and that with Chrome Web Store users or with Chrome users, they are more engaged within your apps. So I'm sure that you want to find out how. So let's do it. The first step that we need to do is build the manifest. And the example here is a little bit meta. What I'm doing is I'm creating a Chrome Web Store app for the Chrome Web Store. And the first thing to do is to define a launch URL, or what happens when the application launches. And in this case, I'm simply opening up the Chrome Web Store URL in a new tab. But there's also other things that you can do, and you can find this within the documentation. Next, we have the permissions. So these are the permissions of the application. Sometimes I want an application that's locally downloaded, so I can define storage space. After that, I have the icon files to use. In this case, I'm defining 16.png and 128.png. So you need two icons, a 16 by 16 icon and a 128 by 128 icon. And lastly, I'm defining some information about the application itself, such as the name, the description, and the version. Once we have the manifest JSON created, we then need to create the images themselves. Again, a 16 by 16 icon and a 128 by 128 icon, and take a screenshot of our application. So the screenshot will be shown on the application page to kind of give users a sense of what the application does. Also optional that you can include are a YouTube video. The YouTube video typically defines what your application does or shows an example of how to use the application. Also, a promotional image. So promotional images are banners that will be displayed at the top of Chrome Web Store or wherever we decide to feature applications that show highlighted applications that we want to kind of show off. And lastly, a customized header background. So this just makes your web page look, or your application page look a little bit more aesthetically pleasing. And as we all know, users love shiny, aesthetically pleasing things. Once we've done that, next step is to take these files and upload them to Chrome Web Store. So first, you need to zip the manifest and the icon files together. Once you've done that, there's only 2 steps in this process. It's quite simple. You simply log into your developer dashboard in Chrome Web Store and upload your zip file. So now you've defined the application. You can take that optional data and include it within the application profile. So first, you can add and define the additional screenshots and promotional images. Then after that, you can pick a category for your application to publish under. So if your application is, say, an educational one, or a travel, or if it's a game, you can define the category so it can be easier found, or to improve its findability. Also, you need to define a detailed description and choose a price point or use a freemium model. So the freemium model is the in-app payments section that I'll be talking about in a little bit again. When you choose a price, it's the upfront price. So again, if you want to pay, or if you want to charge 99 cents for your application itself. Once you've done that, you need to verify your website. So verifying your website ensures that users or developers don't publish an application for a domain that they don't own. So let's say that you try to publish an application for CNN.com, but you don't own CNN.com. Verifying the website takes care of that issue. And next, provide an analytics token. So the analytics token allows you to track how customers or users are engaging on the application page itself. Lastly, once you finish all of this, you can simply click Publish Changes, and your app is published live on the web store for anybody to discover. So once you publish your app, hopefully tens of thousands, hundreds of thousands, or millions of them are using it. We need to figure out how to monetize your application. And one way is through payments, through in-app payments or the freemium model. So these 2 graphs are from Flurry, and they show revenue from both Android Marketplace and iTunes Marketplace. The left graph here shows the top 100 grossing games, and it's split by the revenue model. So the blue section shows premium games, which are pay up front, charge 99 cents for the game before somebody can download it. And the green section shows freemium games, which is a user engages within your game or your application first, and then within the game itself, they make purchases or they convert somehow. And this is a change from January of 2001 to June of 2001. So within 6 months, there was a huge change within how games are monetized. The second graph shows the transaction sizes versus the revenue generated for those transactions. The green section shows orders which are under $10, and the blue section shows orders which are over $20. So here we see the number of transactions, that 71% of transactions are under $10. And here we see the revenue generated by the transactions, and it shows that 51% of the transactions, or 51% of the revenue generated is from transactions of over $20. So at first, these two graphs don't really make much sense, right? Why would people be spending so much money? Why are people going to the freemium model? Well, what it shows is that developers like yourselves have discovered something. They've discovered that instead of charging all users maybe 99 cents or $2 up front, that it might be more lucrative, or it is more lucrative to allow users to engage within the application and then pay the amount that they want to pay. So one person may pay $300, and that one person has made up for 300 of your other users. Also, so this is the growth that we've seen at Google itself. This data is a little bit stale, but it's the only data that PR would give me. And what it shows is the daily transaction growth at Google from June of 2010 to December of 2010. And the transaction, because PR wouldn't give me any hard numbers, I had to use the abstract value of a rainbow. And the number of transactions has not only increased to a double rainbow, but to a triple rainbow. It's beautiful, isn't it? So how can we, now that we know the market, how can we leverage it? Well, Google has recently introduced something called in-app payments. And it allows your users to purchase from within your application without ever leaving your application. And it's a really simple API to use. The key benefit here is that we have a 5% flat fee. So I don't know how many of you work with credit card companies, but they typically charge 2 to 3% plus 20 or 30 cents. So when we're talking about something like microtransactions, where an order may be only $1 per person or $1 per order, instead of seeing around 70 cents with typical credit card processing, you would see 95 cents with in-app payments. Also, we handle PCI compliance for you. So PCI compliance is something that the credit card companies mandate. It's a certification for your back-end servers so that they can store credit card information. And it's typically very costly. I've heard anecdotal evidence of $10,000 to $100,000, depending on the scale of servers. Google will handle all that for you, so you don't have to worry about it. Also, we handle risk management. So Google has a very powerful risk engine, and we run all of our orders through the risk engine to ensure that they aren't fraudulent, or try to prevent as much fraud as possible. Lastly, or next, we have a very simple API, and the API is going to be so simple, I'm going to show you how to implement the whole thing during the slide deck. And lastly, we have millions of buyers. So if you saw on the previous slide, any user who's made a purchase from Android Marketplace, from Chrome Web Store, from YouTube, books, if they purchase something simple like Picasa Web Storage, they've stored their accounts or they store their payment credentials within the cloud. And these payment credentials are accessible by you. Well, not accessible by you, but a customer can complete the purchase with these payment credentials simply by logging in and clicking purchase. For buyers, there's a few benefits as well. They can use one single account for multiple purchases across the web. So think of this as something similar to OpenID, but for buying things. Also, they can purchase with only a few clicks. The purchase flow is very minimal. It's very easy to use. And lastly, the payment credentials are private. So the payment credentials are never shared with the merchant themselves. So hopefully, they won't have to worry about it being hacked. And this is the experience that the user has. They come to your website, they click buy to initiate their purchase flow. They confirm the purchase itself, and then your site will deliver the content that they've purchased. For the developer, it's just as simple. The user clicks buy, your JavaScript initiates a call to the in-app payments JavaScripts, The in-app payment JavaScript dynamically renders a purchase flow. Then when the user confirms the purchase, 2 notifications are sent, one to your server and then one to your JavaScript callback. Lastly, your page delivers the star that they've purchased. And this is the full API picture. So the user will go to your page and request the content. It's rendered. They click buy, which your JavaScript handles, and then calls the in-app purchase or in-app payments API. The purchase flow is then rendered, and the customer confirms the purchase. Once they've confirmed the purchase, the order is now authed. So the auth is the state where money is set aside on the credit card to be paid out later. Once the order is authed, Google then sends your servers a postback. Your servers then need to pull the order ID out of this postback and respond with it to the notification. Once Google receives this response, we'll then charge the order, so the money transfer then occurs, and then we'll send your JavaScript callback a notification as well. At this point, when you receive this callback, your client code should then check with your server to ensure that a real order is placed, because anybody can just open up a dev console and mock your callback. So how do we integrate that? Let's get started. The first thing that you need to do is sign up as a seller, and you can do this at google.com/payments. So once you've signed up, there's a few things you need to copy down. You need to copy down your seller ID and your seller secret/key. These 2 bits of information here. And if you know the postback URL that you're going to be using, you can define it now. Once you've done that, you need to define the item that a customer will be purchasing. We're currently using a JSON Web Token format. So JSON Web Token format is a way to kind of authenticate data that's being passed from the client to the server. So as you all know, anybody can modify data on the client. So JSON Web Token appends a signature to the data to ensure that this data hasn't been modified. There are a few standard fields for JSON Web Tokens. The first one is the issuer. So the issuer in this case would be you, your seller ID. The audience, because you're sending this item data to Google, is Google. The type is Google/payments/in-app/item. This is an item definition. The expiration time is the time since epoch in milliseconds that you define when the purchase will expire. So let's say that you're selling something like a ticket. Then in this case, you only want that ticket window to be open for a certain amount of time. And you can use the expiration time to ensure that it expires exactly when you want it to. And the issue that time is when the JSON Web Token was created. So you need to define this to prevent replay attacks. And lastly, once we have all of that stuff out of the way, we can define the item itself. And in our case, we're defining a piece of cake. And it's a virtual chocolate cake to fill your virtual tummy. The price is $10.50. And we have some seller data, which is information that we're passing from the client back to the server. Once we've defined the JSON itself, then we can use it to build a JSON Web Token. So here I have a few examples of some client libraries, some JSON Web Token client libraries. And it's really simple to use. You simply call JSON Web Token.encode, which is the function that they provide, and you define the item, the JSON item that you previously defined, and your seller ID, seller ID/secret. So that creates your JSON Web Token. Next, you want to do some client-side coding. And this is a simple copy and paste script include. The only thing that you probably need to change on this page is from sandbox to production. So sandbox and production are 2 different environments. In sandbox, no real-world transactions will occur. So you can use this for testing. In production, real-world transactions do occur, so if you test in there, you'll probably be sending somebody money. Once you've included your JavaScript library, the next step is to define your JavaScript functions. So in this case, I have a function called purchase, which simply calls the in-app payments JavaScript, goog.payments.inapp.buy. And what I'm defining here is a JSON Web Token that I previously created, and a success JavaScript handler, a success handler, which is a JavaScript function to handle success, and a failure handler, which is a JavaScript function that'll be called if the transaction somehow fails, if they cancel or if there's an issue with a card. Once I've done that, I can simply add a handler onto my button that calls the function itself. And that's all of your client code that you need. Next up is the server code. So I'm typically a Java guy, but I wrote this in Python because if I did this in Java, it would probably be the rest of the slide deck. Within this, I'm creating a request handler, and then from the request handler, I'm pulling out the JSON web token. From the JSON web token, I'm decoding it back to JSON, and then I'm pulling out the order ID, and I'm responding to the request with the order ID. And that's it. I've implemented in-app payments in a few simple steps. It's so simple that I've actually included it in my slide deck, and I can purchase something right now, hopefully, if Sandbox isn't too bad. So I simply log in. I think I mistyped my password. And complete my transaction. Hopefully this one will complete. It's Sandbox, so it might be a little bit slow. I'll cancel. I don't want to keep people waiting. So the first purchase took place in a pop-up because I'm not logged in. But if I were logged in, I would click buy again, and the purchase flow takes place in an iframe. Simple, right? And looks pretty good. This data right here is actually the failure callback right now because I didn't complete the transaction successfully. So that's pretty much the entire flow for in-app payments, but there's also a few more other things to pay attention to. With the seller data that I was referring to earlier, you can do a few things. It's primarily used to tie information from the client back to your server, and you can use it to do things like identifying the user. So you can say that this user purchased this good and record that on your server. You can also say this user made a purchase on this sale and pass that back to your server as well. But because all this information passes through the client, you should always be sure to encrypt it. And the last piece of securing your content is to make sure that you always implement server-side checks. So for anything that is purchasable on your server side, be sure to check that a customer has actually purchased it before granting access. Also, you should compile, obfuscate, and minimize your JavaScript. So in this example, I mean, there's a lot of good tools out there. There's Yahoo's JavaScript compiler, but Google has something called the Closure compiler as well, that some of you may be familiar with. And this is a simple example. I have a simple JavaScript hello world function, and I'm running the compiler against it, providing the file itself as a parameter and providing the output file as a second parameter. And the output is this minimized and obfuscated JavaScript. There's also a lot more, so this is the most basic obfuscation and compilation that it does. There's also a lot more advanced features and advanced functionality that you can find in the documentation for the Closure compiler. And lastly, with in-app payments, I'm sure most of you know that Google is somewhat a little bit of a US-centric company. And typically most things are launched in the US first, which is the same case for in-app payments. But I'm happy to announce that today, we are now available, at least in Sandbox, in Japan. So you can go to the Sandbox environment and sign up as a Japanese developer. And in the very near future, we'll be available in production. So then you can accept real currency or real transactions. So now we are on to the last piece of the puzzle, which is advertising, right? And why do you want to advertise? The most important number that you want to see here is that 82% of users are willing to watch a 30-second pre-roll ad. So some of you may already be familiar with this. If you've ever watched YouTube recently, you've probably noticed that there's an ad that plays before the videos you want to watch play. And I agree, it's a little bit annoying, but then developers like yourselves need to get paid somehow. Another good statistic is that 36% of all 30-day internet users are casual gamers. So we've come up with something called AdSense for Games. And AdSense for Games is video or flash ads that play within your game itself. Contextual video and contextual flash ads for your games. And there's a couple of different places where you can place these ads. The first place is that ads can be shown before or after or even during gameplay. So this would be a video that occurs during gameplay. Or you can show an ad during loading. And there's multiple formats for ads. There's AdSense video ads, which in this case, you can show pre-roll, mid-roll, post-roll. You have control about where you place these ads. And the ad length, typically all of them are under 30 seconds and can range between 15 and 30 seconds. You can also choose to have these ads shown contextually. So you can choose a region, you can choose an age demographic, you can choose even a gender. And lastly, these are all based on the cost per mile model, so cost per 1,000 impressions. We have a second type of ad format, which are the static ads, the AdSense flash ads. And these are all really relevant from our huge advertising network ads that can fill 100% of your ad inventory. So all the ad placements that you have on your page, the most important takeaway from this is that we can fill 100% of it. And for these ads, we have both cost per click and cost per mile models. So I'm going to take a little drink. Once you've implemented these, you also need to be able to track how you're generating revenue. And AdSense for Games has a great UI for tracking. We have reporting tools so you can track the revenue generated along with how your pages were viewed. And you can also segment the users out. So you can see where your users were coming from, you can see what they were doing, and then try to focus on your most lucrative market. And lastly, you can filter the ads that you don't want. So we don't have a whitelist system where you can select the ads that you do want, but we do have a blacklist system where you can select the ads that you don't want to display. And I'm sure you're all very excited about how do we implement these ads now. But before we get to that, we're going to have to watch an ad because I know that everybody loves ads, right? Let's give it a second. Great. Looks like 100% of you didn't mind watching an ad. So how do we do this? Well, this right now is only in Flash. So all of this is in ActionScript 3. We're working on providing an HTML5 library as well. But for the time being, this code sample is in Flash. I apologize. The first step is to import the library itself. So we're importing com.google.ads.instream API. And the second step is creating the ads request. And there's a few required parameters in this step. So we're defining the size of the ad with the first two. And we're defining the publisher ID. So this is our test account ID, CA video AFE test. We're defining the video type that we want. And lastly, we have the content ID. So the content ID is the ID that you use to track your placement of the ads. Once we've defined those fields, we have a few optional parameters as well. We have the channels, which is kind of like the category of ads that you want. So you can define things like sports or entertainment. We also have a description URL. So as many of you may know that Flash is kind of hard to parse, right? So instead, you have the option of defining a URL that will actually crawl to get a better idea of what your game does. So we can better target ads. Next, we have a demographic field for the age group that you expect. So let's say that you're developing a game about ponies. right? You would expect a certain age group to play that game, and you want to target that age group with your ads. And lastly, you can define the gender that you want to target as well. There's a few optional parameters. So ad tests defines that you're actually testing. If you leave this on, you won't get paid out. So you probably want to turn this off. Also, we have the language. So in this case, you can define the language that you want the ads to appear in. The total ad duration, how long do you want the ad to play? And unique ads. So this one will only display unique ads through ad placements with the same content ID. And lastly, you have the ad time position. So this one will allow you to define where the ad starts. So maybe you want to start a second in or 2 seconds in. You can use this parameter. Once we've done that, we need to create a new ads loader. So right here, we're instantiating the new ads loader. Then we're adding a few event listeners onto it. So we're adding the ads loaded. So this is called when the ads are finished loading, and we have an ad error, so if anything should happen with it. And finally, we request the ads. So once we've requested the ads, then we need to handle the ads themselves. And we can do that through an ads manager. So we're pretty much pulling out the ads manager from the ads loaded event. And then we're adding a few more handlers onto that. So yeah, I know there's a lot of handling going on. In this case, we're adding an on-ad error, and then a content pause and a content resumes. Once we've done that, we can actually handle the video itself. So from the ads manager, we're now pulling out the video ads manager if the ad type was a video. Then to that video ads manager, we're adding a few more handlers, one to define when the video is completed and one to define when the video is actually clicked on. And lastly, we play and show the video itself. For our other Flash type, for the other static type, which is Flash, we have a ads manager for the Flash type as well. And it's a little bit simpler. We simply start up the Flash. And lastly, we have a error handler. So that's it. This is a really easy API to implement if you have a very popular game and you want to monetize it. And right now, it's in private beta, but the good news is that it's open for all of you. So just come and talk to me during the office hours, and I can help you talk with the team on getting you added to the private beta. And that's it. So there's a few key takeaways here, that distribution and monetization are some really important aspects of making a game successful. And I've shown you 3 products that can help you distribute and monetize really, really easily. We've implemented all these APIs in under 45 minutes. So really simple way to do it. The first one is Chrome Web Store. And it's a simple way to reach 200 million users and distribute your app across the world. We also have in-app payments. And we found that it may be more lucrative to charge nothing up front, have users engage within your application or within your game, and then allow them to pay however much they want. And lastly, if you already have a popular game or an application, that advertising can be a really easy way to monetize. So here are some resource links. The first one is Chrome Web Store. You can find apps there, or you can sign up to be a developer and distribute your apps there. The second one is Google in-app payments. So there you'll find sign up and documentation. The next, closure compiler documentation. You can use this to minimize and obfuscate your JavaScripts. We have some AdSense for games ad documentation. So the next 2 are AdSense for games and the interactive media ads SDK. HTML5 Rocks is a great site for learning by tutorial. And then we have HTML5 Boilerplate, which is a great foundation for your web page. It handles a lot of the cross-browser compatibility issues, so you should always build your web pages on top of HTML5 Boilerplate. And we also have Modernizer, which is a JavaScript tool that allows you to programmatically test what JavaScript functions are supported by the browser. Can I Use is a website that shows compatibility tables that shows what CSS functions and what JavaScript functions are supported by certain browsers. And lastly, if you're interested in monetization, or if you have any questions for us, you can follow us on Twitter at Google Commerce Dev. And that's it. If you're interested, or if you want to find the links and you didn't copy them down, you can actually find my whole slide deck at this URL, bit.ly/GDDmoney. Thank you for coming, and I hope you learned a lot.
以上でセッションを終了させていただきます。